So after discussing the three kinds of constructors, the default constructor, the parameterized constructor and the dynamic constructor, we now move on to the final constructor called the copy constructor. But before that we need to know the default copy constructor. Like we have a default no argument constructor and we can also make our own no argument constructor. Similarly, we have a default copy constructor, but we can also make our own copy constructor. So what is the default copy constructor? When you initialize an object with the another object of the same type, for example, you have an object of type distance d1 10, 6.25, okay, and you create another object of the same type d2 and you write d2 equal to d1. So what are you doing here? You are initializing d2 equal to d1. So d2 must be the exact copy of d1. So here this is the memory allocated to d1. d1 contains values 10 and 6.25 for its data members, and here we are assigning d2 is equal to d1. So d2 is also a copy of d1 and it will also contain the same values for its data members. Okay. So what are we doing here? How is this done? This is done using the copy constructor. Okay. And but you can do this and you do not write any copy constructor. Okay. Then how is it done? It is done using the default copy constructor. If you do not create your own copy constructor, default copy constructor is created by the compiler, and whenever you are making the assignments of this type, that is assigning an object of one object of a type to another object of the same type, then the compiler automatically calls this default copy constructor. But if you create your own copy constructor, then the default copy constructor is not created by the compiler. Okay. So, as I already told you that you do not need to create any special constructor for this. It is already built into all the classes. So, compiler automatically generates the default copy constructor. And it is a one argument constructor whose argument is an object of the same class as the constructor. So how does this copy constructor look like? Taking the same example, this is suppose class distance. It has two data members, int feet and double inches. Although you do not create your own copy constructor, this is already there. So how does it look like? Because this is a constructor, so it will have the same name as the name of the class, and it is a one argument constructor. What is the argument passed here? The object of the same class as the constructor. So this object is passed. And how are we able to make a copy? So it is like feet is equal to, suppose this is d dot feet, and inches is equal to d dot inches. Okay, so the default copy constructor looks like this. So whenever you write d2 equal to d1, then this copy constructor is called. Okay, so it means you can also write it as d2 d1. Okay, so both are the same things. So it means you are calling the constructor and you are passing as argument the object d1. So d1 will be copied here, d will be equal to d1, and here inside the body, what are we doing? Feet equal to d dot feet. What is feet here? feet belongs to D2. Why? Because this copy constructor is called by D2. Okay. So it means D2 dot feet is equal to D dot feet means the D is the argument. D is the formal parameter. And D is the formal parameter. What is the argument passed to this formal parameter? D1. So it means D2 dot feet is equal to D1 dot feet. And similarly, D2 dot inch is equal to D1 dot inches. So this is the format of the default constructor. This is how the default constructor works. Okay. Now you can define your own copy constructor also. Okay. So the default constructor which uh, you use, which is automatically created by the compiler, that makes default member-wise copy. Means the values are copied. Okay. Suppose whatever value is there in the feet and inches of D1. Suppose this feet contains 10 and this inches contains 5.5. These values, same values will be copied. This is D1, suppose this is D2. Same values will be copied here. So this is the member-wise copy, 5.5. So it cannot deal with pointer numbers. How can we say that? Let us take another example to explain this. Suppose you have a class dummy. Okay, and it contains two normal variables, int a comma int b, but it also contains a pointer variable, int star b. Okay, and in the public section we have a constructor dummy, and we have some variables, int x, int y, and int z as the formal parameters. So a is equal to x, b is equal to y, and p is a pointer, so it will contain the address of an integer. So let us allocate memory to it. So we have allocated memory to this pointer. So star p is equal to z. This is the constructor. So what is it doing? When the object will be created, then suppose the name of the object is D, then memory for A will be created, memory for B will be created, and memory for P will be created. Okay, and P is equal to new integer. Okay, so P will contain the address of a new integer. So this new integer will not be the part of this object. Okay, so why is this new integer not the part of this object? Because this is not a data member. We have only three data members, A, B and P. So only these three are the part of this object. Any extra memory which we are allocating inside any constructor, that is not the part of the object. Although we can access that memory using this pointer, because this pointer will store the address of this memory. Suppose here we have allocated this new int. New int means this will allocate memory to an integer. So this is the integer. Okay, and it has been allocated memory using the new operator, and this memory has some base address. That base address will be stored in P. It means P is pointing to this memory, but this memory is actually not a part of this object. Okay, although we can point to it through this pointer. This is not a data member. This memory is not a data member. The only data members are A, B and pointer P. Okay. So this is our constructor. So and let us end this class here. And in the main, let us create a create an object. Okay, so dummy d 10 comma 20 comma 30, these are the values which we are passing. So this 10 will be copied to this formal parameter x, 20 will be assigned to y, and 30 will be assigned to z, and a equal to x, so a will be 10, b equal to y, b equal to 20, and star p, that is the memory to which p is pointing, is equal to z. So this will be equal to 30. Okay, so this is happening. Now let us create another object, dummy d2. Okay, and d2 is equal to d. Okay, so here we are making use of the copy constructor, but we have not created any copy constructor here. It means we are making use of the default copy constructor provided by the compiler. Okay, then what will it do? It will do the element wise copy or the member wise copy. So whatever values are there in these variables, all these values will be copied into the member data members of D2 also. So D2 also has three data members, A, B and pointer P. So D2 is equal to D, it means A is equal to 10, B is equal to 20 and P is equal to 1000. It means P is also pointing to the same memory location. Okay, so this is what is happening using the member wise copy. Now imagine that we have also created a destructor here. Okay, so suppose this is the end of the main function, and this is the constructor which is also the part of this class. Destructor starts with a tilde, it takes no arguments, and the function of the destructor is to release any memory which is held by this object. Okay, so is there any memory held by this object D or D2? Yes, this is the resource which is held by them. Okay, and how to free this memory? The memory is allocated using new operator and memory is released using the delete operator. Okay, and let us write delete, and this is the syntax, delete P. What it will do? It will release any memory which is held by P. Okay, so what will happen now? This here D object, let us reconsider the program execution, okay, so that you can understand the things more properly. So when you reach main, D object will be created. So 10, 20 and 30 values will be passed. So the pointer will point to an integer which contains value 30. Okay, so this object now exists in memory. Then we created another object D2. D2 is the exact copy of D1, D. So it will also contain the same values. So this memory resource is pointed to by two pointers. Okay, and when we reach the end of this block, when we reach the end of the program, then before ending the program, all the objects will be deleted, and before deleting any object, the destructor will be called. Okay, so D2's, what is the order of execution of destructors? You might remember the order of destructors is reverse as the order of constructors. Okay, so first D2 will be released, D2's destructor will be executed, and then D1's destructor will be executed. So when D2's destructor is being executed, then what it will do? It will release this resource. Okay, it will delete this resource. Okay, and now this resource does not exist in memory. And next, after D2's destructor, D's destructor will be executed, and D2 is also trying to release the same memory which has already been released. Okay, so this is a problem. So uh, element wise member so we can conclude from here. Let me erase this now. So for objects without dynamic members, that is without pointers, default member-wise copy can do the job. It is okay for the objects which do not have any pointers to use the default copy constructor. But for objects containing pointers to other objects, default member-wise copy will only point the pointers of the two objects to the same other object, as we saw in this example. Okay. So now what is the solution to this? The solution is to define your own copy constructor. And the copy which we did in the previous example, that is called the shallow copy. Okay. So shallow copy means you copy the exact values. The values of one object's data members are simply copied to the data members of the other object. Okay. And in case of pointers, what we need? We need a deep copy. Okay. So deep copy means in the previous example, if this is A, B and P of D, and P is pointing to some memory location, okay, then deep copy will make another object D2. It will also contain the same members A, B and P, but now P will not point to the same object. It will create its own object and point to this. Okay, and this is called the deep copy, and this can be achieved by defining your own copy constructor. Okay. So when a copy constructor exists, the default copy constructor is bypassed. The compiler does not create its own default copy constructor. Rather, the copy constructor created by you is used. And in the copy constructor which is defined by you, you perform a deep copy. Okay. And what is the syntax of creating the copy constructor? The class name, because this is a constructor, therefore it will have the same name as the name of the class. And here we have const class name ampersand o, and this is the body of the constructor. So why we write const here and why we write ampersand here, I will tell you when we write the program for the copy constructor. At this point, just note that you have to write the name of the class, suppose distance, and the name of the object followed by a preceded by a parenthesis. Sorry, ampersand. Okay. So O is the reference to the object here because we have put the reference operator here. Okay. And it is permissible for a copy constructor to have additional parameters as long as they have default arguments defined for them. You can have any other parameters here also, int I, etc. Okay, but this is compulsory. This is the default argument. Okay, so this must be the first argument. And as I told you, in all cases, the first parameter must be a reference to the object which is doing the initialization, right?